Rational expressions and functions 4.1. So these first ones are just trying to get us in the habit of dealing with fractions, because we're dealing with fractional functions, okay? That's what rationals are. So what they want us to do is to simplify this by finding ways that we can get the same number on the top and the bottom, which would then cancel out. So 18 and 24. Well, 18 is like 6 times 3, 24 is 6 times 4. So the 6 over 6 is like 1. 1 times anything leaves us with that. So that's what you're doing on all of these. So I'm pretty sure you guys could figure out most of these ones on your own. I'm trying to look at some that might be a little more difficult to get. 18 and 45, 2 times 9, 5 times 9. The 9's cancel out, so 2/5. Okay, number 5, 8 would be like 1 times 8. 24, 3 times 8. 8's become 1, so you get 1/3. Number 8, you can do 7, right? 5 times 7, 8 times 7. 7's cancel out, so you get 5/8. So I think you guys should be good on the rest of those ones. Alright, now taking a look at graphing these. Okay, so we want to find, kind of just get a handle for what the graph looks like. So we can start plugging in some numbers. Now, normally we always tell you guys to plug in a 0 for x. But what happens if I put 0 in for x? Okay, that becomes undefined. And we can't do it. So we don't want to do that one. So we should probably pick a few numbers, maybe like -4, -3, -2, -1, 1, 2, 3, 4. I'd actually probably want to extend this to get a better picture of what's going on. So notice that anything I put is going to make it a fraction, right? So -4 would be -1/4. Okay. -3 would be -1/3. Whoops, that should have been a 4. Or 0.25 for those that like that, -0.25, or -0.333 repeated. Okay, -1/2 or -0.5. -1/1 would be -1. +1 would be 1. 2 would be 1/2 or 0.5. 3, 1/3. 3, 4, 1/4. 0.25. So let's take a look and graph these points. So, and kind of get an idea of what's going on here. So, if we go back to -4, we're going down to -0.25, so right about there. At -3, we're a little further. At -2, we're at 1/2. At -1, we're down here at 1. Okay, and then if we look at the other ones, 1, we go up to 1. And then at 2, we're at 1/2, at 3, 1/3, then 1/4. Okay, so it's kind of tough to see what's going on here, isn't it? That's not really giving us much indication. We need to find some spaces in between. So, think of it this way. Let's say we chose, for x, 0.5. So what's 1/1/2? Well, that would be like 1 divided by 1/2, which we'd flip it and multiply, so it would be 1 times 2/1, which is just 2. So if I go to 0.5, it's up to 2. Okay. Same way, what if I divide by 1/3? Well, that's the same process. We end up with 3. So at 1, we have 3. At 4.25, we're up to 4. Okay. Same way with the negatives. The negatives would just take us that same way. So they kind of look like two exponential equations, don't they? So that it looks like it's going like this, and it's going like this. Now, that 1/0 being undefined means that there's an asymptote right here. Okay, an asymptote is that invisible line we never cross. There's also one here on the x-axis, just like with the exponentials. Okay, so, because if you think about it, can I ever get 1 over some number to equal 0? The only way to do that is if the top number is 0. So that's not going to work. So there's nothing there. So that's what it looks like. Okay, that's what it looks like. Now, domain and range. Okay, the range, we keep going down, we keep going up, but we don't hit the middle. So we'd say from negative infinity to 0, union, from 0 to positive infinity. Okay, so saying that it jumps that x-axis. So the domain, same idea. We go from negative infinity to 0, and then from 0 to positive infinity on the x. Okay? Because it skips that y-axis and the x-axis, it jumps over it. Okay, increasing and decreasing. Well, from here to here, it's always decreasing as we look left to right. How does it jump from down here up to here? That's a mystery. But it's still decreasing. So the decreasing would be the same as the domain. And it's never increasing. So same as domain. So you could just rewrite that. Oops. A max and a minimum, we don't have those. Okay. Discrete or continuous. Remember, continuous means we connect the dots. Discrete means we would just have the dots. Well, we can have stuff in between, so it would be continuous. Does it have any x or y intercepts? Nope. Positive and negative? Yeah, on the right side, it's positive up here. So that would be from 0 to infinity, it's positive. Negative is the left side. So that would be negative infinity to 0. Is there anything we missed? The asymptotes would be one that you'd want to write, and this is how you spell it. Oh, there's a P in there. Hold on. Like this. Okay, we have an asymptote as y equals 0 and x equals 0. So that's the main points there for that one. Okay, so there's a lot of stuff we're lacking, isn't there? So now let's say, what if we made it negative? Well, think about, what do those transformations mean when we make a function negative? If it was a quadratic and we made it negative, it would just flip it, right? So that's going to do the same thing for ours. So basically we're taking all this stuff and we're just flipping it. These become positive, these become negative. So if I went negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4, it would be positive 1/4, positive 1/3, positive 1/2, positive 1, negative 1, negative 1/2, negative 1/3, negative 1/4. So we're just reflecting it over that x-axis. So it would look more like this, right? We still have that asymptote right here. We still have that asymptote right here. So for our features, the asymptote's the same. The domain and the range are the same. Okay, but instead of decreasing now, it's always increasing at that domain. Still doesn't have a maximum and a minimum. It is now no longer decreasing. It is still continuous. It doesn't have any x or y intercepts still. So it's very similar just because we flipped it. Okay, same as 1 over x except for it's increasing on the domain. That's really the only thing that changes. So there's kind of the visual as we're working with these expressions over the next few days. There's a good visual of what these graphs can kind of look like. Okay? Alright, so now let's just simplify. So simplifying is just like we were simplifying over here, these fractions. So we've got to find what's the same. So a good idea sometimes is to kind of factor it out. 28, 4 times 7 times n. 70, 7 times 10 times n times n. Well, that 4 could be 2 times 2, right? So we could break that down further. 10 could be 2 times 5 times 7. So what's the same on the top and the bottom? So we can also cross out the 7's and the n. So we're left with 2 on the top and a 5 and an n on the bottom. Okay? So on 13, same idea. We can look for what we can pull out. So these share 9s, right? So I can pull out a 9. That would leave me 5k plus 2 over, if we pull out a 9, we end up with 3k plus 10. So I can cross out the 9, so I end up with 5k plus 2 over 3k plus 10. Okay, 14. We've got n plus 2 on the top. The bottom, I can pull out a 2 and an n, leaving me with 2n, n plus 2. So I cancel those out. Now, whenever you cancel the whole top part out, it would just become a 1. So it's 1 over 2n. On 15, we treat it the same way. I can pull out a 2n, so that would leave me with n plus 6. And then I can pull out a 7n squared, leaving me with n plus 6 again. Because of this multiplication, I can get rid of the whole n plus 6. I'm left with 2n over 7n squared. Number 16, now we're going to have to factor this one using the box method. So I've got 7v squared. I've got 48. We take 7 and times it by 48 and get a calculator out. So 7 times 48 gives us 336. So 336, factors of 336 that add up to a negative 62. So they're both going to have to be negative, basically. Right? Now, I'm going to use this to help guide me. What if I got a 336 divided by 8? Gives me 42. That's not going to work. Right? Because 8 and 42, they're both negative. That'll give me 50. So 336 divided by 9. Nope. 336 divided by 10. Nope. 336 divided by 12. 12 and 28. They're both negative. Is not going to give me that negative 62, is it? So, let's try 336 divided by 13, 14, and 24. That's not going to work. 16 and 21. Okay, so I had to do some extra work, but I found it. Negative 6 and negative 56. Because that would add up to negative 62. So negative 6v, negative 56v. Now, 48, we can change that one. That's like negative 6 times negative 8. 56, we can change that one. That would be like negative 8 times 7. So I can pull out a 7v, I can pull out a negative 6, pull out a v, pull out a negative 8. So I get 7v minus 6 times v minus 8 over v minus 8. We can cancel out the v minus 8s. 7v minus 6 is our answer. Alright, now the last three. Finding solutions for the polynomial functions. Find all of the solutions for the given polynomials. So, we want to find out what x is. So the best way to do that is to get all the numbers on the same side. See, 3 minus 15 would be negative 12. Okay, equals 0. What are the factors of negative 12 that add up to 4? Well, how about positive 6 and negative 2? So then we set these equal to 0 separately. And we get x equals negative 6 and x equals positive 2. So basically we're using that factoring, we're finding the zeros here. So subtract 60, we get x squared plus 6x minus 55 equals 0. So factors, if I could use the box method, but with these simple ones I think it's easier to not. So plus 11 minus 5, that would give us positive 6. So I know that x is going to equal negative 11 and positive 5. Okay? That last one is already set up for us, but the first step they all have x, so I'd pull out an x to get x squared plus 5x plus 6 equals 0. Then I can factor that, so I still got that x. Now the factors of this one would be x, let's see, plus 6 would be 2 and 3, right? X plus 2 times x plus 3. So we can, each one of these set equal to 0 on its own, and then solve. So x would equal 0, because we can't do anything to that. Subtract 2, negative 2, subtract 3, and negative 3. There we go, guys.